Okay, so the next chapter that we're going to move into is a chapter on statistics. And the first lesson that we're going to do in this chapter covers the different kinds of data that we might collect as we're working with statistical information. Here's the objectives for this first video. We need to know what a statistical variable is, and then we also need to know what kind of data that a specific variable is measuring. So the way this will look is you will have a question that says, hey, I made a survey and I chose to ask people what kind of food they like to have when they go out for dinner. And then based on that, you need to decide what's the variable and what kind of data is that variable measuring. So let's get started. First of all, what is a statistical variable? A statistical variable is a characteristic or a quantity that is measured for the purposes of collecting data. Now, this is very different than an algebraic variable, where we typically have a letter or something that represents an unknown or represents something that's allowed to change. This is very different. In statistics, the variable is the thing that we're measuring. So again, if I had a survey where I asked people what kind of food they like, my variable is the type of food that they like. That's what I'm measuring. And so as they respond in my survey and I have a list of different foods, that data set of all these different foods is the answer to this particular variable. It's the thing that it's the question I'm asking. It's the thing that I'm measuring. So that's a statistical variable. Once I start collecting data using statistical variables, there are different kinds of data that I might collect. The first is called qualitative. It is sometimes called categorical. The example of what kind of food do people like would be an example of qualitative data, because what I can do is, based on their answers, I can divide that data up into different categories. These people like beef, these people like chicken, these people like fish, etc., etc. So that's one type of data. Another type of data is called quantitative. This is data that involves quantities, sizes, lengths, numbers in general. Quantitative data can also be subdivided into two other things. There's quantitative discrete data, and then there's also quantitative continuous data. So the quantitative data can be further broken down into other categories. When you're working through problems in this chapter, the three answers that you could potentially give to the types of data is that it's either qualitative, or it's quantitative discrete, or it's quantitative continuous. So those are the three categories that we're going to focus on. Let's talk about the first one. Qualitative data, sometimes called categorical data, is data that describes a quality or a characteristic that a specific data points have. So for example, we could talk about hair color, we could talk about pizza topping, favorite kind of car. I've already mentioned food that people like to eat for dinner. All of these things are characteristics or qualities of my statistical variable that lets me break that data set up into different categories. And so this is what qualitative data is all about. So the next thing we have is quantitative data. Quantitative data is different because this type of data requires numbers in order to provide the answers. So the examples of how tall is somebody, how far are two things away from each other, how long does it take to get somewhere, how many people are at a particular event. All of these questions would require the use of numbers to provide an answer. So those are all examples of quantitative data. Now, you have to be careful though. Just because a data set has numbers in it, that does not necessarily make it quantitative data. So let's build this idea a little bit further. Generally speaking, if your data set has numbers, then the size of the number has to be indicative of the importance of the data point. Here's what I mean. If I take a bunch of people and I rank order them based on how tall they are, then the one who has the biggest number is going to be the tallest person, and the one that has the smallest number is going to be the shortest person. Now that would be very different than if I ranked ordered them based on what's their social security number. That would tell me, that would seem fairly random, and that's probably because social security numbers are assigned in a very weird sort of way. So the height of a person is numbers that is quantitative, but their social security number is numbers that is qualitative. It's not the same kind of a number. Here's another example. Right now, as we record this video, the NCAA basketball tournament is occurring. So if I were to make a list of all the teams in the basketball tournament and I rank ordered them based on their seeding, I've got a 1 seed, a 2 seed, a 3 seed. What I've got in that situation is the lower the number, theoretically, the better the team is. Those numbers mean something that's quantitative. But if I asked you to make a list of all the TV stations that are currently airing the tournament, your list might say, well, Channel 5, Channel 25, Channel 162, Channel 1805. But those numbers, it doesn't mean that the game on Channel 5 is better or worse than the game that's on Channel 25, right? It's just two different channels. Those numbers really more are like the name of the channel than they are some quantitative property that the channel has. So in that situation, I've got numbers, but the numbers would be considered qualitative. So you've got to be careful with numbers. Generally speaking, they're quantitative, but not always, and you've got to watch out for those exceptions. So as I said before, there are two types of quantitative data. The first kind of quantitative data is known as discrete data. Discrete data is data that by its nature cannot be subdivided into really small parts. So what do I mean by that? I mean, well, one of the examples I gave earlier were the number of people that were at an event. If I'm counting people, I can only go down to the smallest I can have is one person. We never have a scenario where there's a half of a person running around. That's a situation where the data is discrete. The nature of the data makes me stop with one being the smallest number. So a big hint is that if the whole entire data set by its nature cannot have decimals or fractions, then it's probably discrete. So I already mentioned an example would be counting people. Whether it's people in an event or people who attend Midland High School, whatever it is, if I'm counting people, I never have a half of a person. I never have a fifth of a person. That doesn't happen. But there is a scenario you have to watch out for. Money. Let's say I told you I had $1.25 in my pocket. The way I would write that on the piece of paper is 1.25. That's how much money is in my pocket. But what does that mean? That doesn't mean I have 1 1/4 of things in my pocket. It means all the money in my pocket added together is equivalent to 125 pennies. So even though I write it with a decimal, what it's actually measuring is the value of the money based on the number of cents it's worth. And since I can't have a half of a penny or a quarter of a penny, money by its nature is discrete. Now, continuous data is a little bit different. Continuous data, the nature of it allows it to easily be broken down into smaller and smaller and smaller parts. And so an example of where we typically use continuous data is when we make measurements. So if you think of all your examples from your various science classes, and you think of all the rules that your teachers taught you about dealing with measurements, those are probably all things that talk to the concept of continuous data. For example, if I'm measuring something and I can only measure it so far because the instrument I'm using is only so accurate, that's continuous data. Or maybe the instrument I'm using is only has a certain amount of precision associated with it, right? A ruler has a very different precision than a micrometer. And so because of that, a ruler I can only measure to maybe 1/4 or 1/8 of an inch, depending on the ruler I'm using. But a micrometer I can measure to maybe 100th or 1,000th of an inch. And so very, very different. And of course, as you've learned in science class, if you're dealing with these different scenarios, then significant figures become very important. If you're working with data sets where these types of ideas and concepts are associated with the data points, then that's probably continuous data. Here's an example. How tall a person is. If I measure a person using a yardstick that's just blank, I'm not going to get a very accurate answer. But if I measure them using a yardstick that has inches on it, I'm going to get a more accurate answer. If my yardstick has half an inches or eighth of an inch on it, I can get even more accurate. And so just because of the nature of my measuring tool, I'm allowed to take the data and get it down into smaller and smaller or more accurate pieces. That's continuous data. Okay, so that takes care of the video. The objectives that we had were to know what a statistical variable is and to identify the different types of data that we might be measuring. So hopefully at this point, these are things you can do. If not, then obviously you can go back and watch the video. You can ask questions in class, whatever you need to do. The next video will be moving into how to display different kinds of data sets. And so, in fact, actually the next several videos will be just about how we represent data. So hopefully this has helped you. Thank you for watching.